Alright, here are additional examples that are quite similar to the problems that are in your problem set number 3 or problem set for module 3. Okay, we have here a bungee cord which is 30 meters long, and when stretched at a distance x, it exerts a restoring force of magnitude kx. Your father-in-law, with mass of 95 kilograms, stands on a platform 45 meters above the ground, and one end of the cord is tied securely to his ankle and then the other on to the end of to the platform. Okay, you have promised him that when he steps off the platform, he will fall a maximum distance of only 41 meters before the cord stops him. And so you had several bungee cords to select from, and you tested them by stretching them out, tying one end to a tree and pulling on the other end with a force of 380 newtons. When you do this, what distance will the bungee cord that you should select have stretched? Okay, let's try to visualize the problem first. Okay, I'll try to draw, although I'm not a good drawer. Okay, and so say for example, this is the platform for the bungee jump. Okay, and so it says there in the problem that it is 45 meters. So if this is the ground, this is, and so 45 meters. Okay, that's 45 meters high. All right. And then, and so your father-in-law stood here initially. All right. And so the mass is, and so the mass of your father-in-law is 95 kilograms. Right. What else? It's given. What else is given? You have there 30 meters. And so meaning, and so when your father jumps to the or jumps off the platform, and so for example, this is now the equilibrium point, and so usually bungee jump is ano, diba, upside down. So for example, this is now this is not to scale ha, that is the 30-meter long, wherein it's on its original length or equilibrium length. Okay, and then of course your father, I mean, you promised that, and so you promise that it will only, and your father will only fall a maximum distance of 41 meters. So for example, and so dito lang siya, ayan, parang dito lang may stretch um, yung father-in-law mo. Alright? And so ang hinahanap natin is that what will be the distance. And so ano yung distance? I mean, yeah, ano yung distance nung tinetest mo pa lang yung bungee cord? Kasi, meaning, alam mo na yung, na-compute mo na yung distance nung nag-bungee jump yung father-in-law mo. Meaning, na-determine mo na yung value ng K para, and so, ma-associate mo siya dun sa new situation. Okay, so, tingnan muna natin yung case dito bago tayo pumunta dun sa testing mo dun sa bungee cord. Right? This will be the first point. So, ito yung magiging point 1 natin. And then dito, yung magiging point 2 natin. Okay? Your father-in-law started from rest. So, definitely, V1 is equal to 0. Okay? At the same time, and so dito sa, V2, it's also 0 kasi eventually, mag-i-stop siya at that certain point. Okay? Now, what else? What else do we know? Dito, and so we can say that y1 is equal to 45 meters. Or pwede rin naman na since yung motion natin is pababa, balik rin na lang natin para mas madali yung pag-compute natin. Okay? And so we can say that y1 is 0. And so pag ganun tayo ha, para dito, sa y2 natin, dito tayo magne-negative 41 meters. Kasi nga pababa siya. From dito, sa point 1 natin, bababa siyang ganyan, papunta dun sa point 2. Okay? And so what else? What else do we know? Tignan natin dito, no? We have there x2, x1, and so parang yung, or sabi na, ay, x1 dito. x1 and then x2. And so this is, and so 30 meters. And then ito naman is 41 meters. Okay? And so, pwede na natin makompute dito pa lang na yung elongation natin, yung delta x natin, is equal to, and so 41 minus 30, so that will be 11 meters. So yung delta x natin is 11 meters. Okay, now, let's compute. And so definitely, and so using the law of conservation of mechanical energy, and so pwede natin, and sulat natin K1 plus, and so the gravitational potential energy, 1 plus the elastic potential energy, and then that's equal to K2. Wala naman tayong non-conservative forces, so hindi na natin isusulat yung work by the others. And then we have there UG2 plus U elastic 2. Okay? At this point, pwede na nating i-eliminate yung mga terms na 0. So we know that it started from rest, and then at point 2, it's also at rest. So pwede nating i-cancel out. Ay, tanggalin na natin yung term na to. And the kinetic energy at point 1 is 0. The kinetic energy at point 2 is also 0. Now what else? And so, pwede nating masabi na yung dito sa point 1 natin, 0 din yung gravitational potential energy. At the same time, nasa equilibrium point din. So, 0 din yung natin, yung elastic potential energy. We are now left with the gravitational potential energy at point 2 and then the elastic potential energy at point 2. Okay, so that is 0 is equal to and then gravitational potential energy at point 2. Let's have that as, and so mgy, so ulit ko lang muna ha, plus, dito naman sa elastic potential energy, 1/2 kx squared. Take note na, pababa tayo. Pababa yung yung ginawa natin. So, be careful tayo dun sa negative. So, pwede nating ilagay dyan agad yung negative. And negative mgy plus 1/2 kx squared. And so, lipat natin yon. Mgy is equal to 1/2 kx squared. We are solving, kasi meron tayong value ng mass, meron tayong acceleration due to gravity. We also have y. And then we also have now the change in, and the elongation. Okay? So, pwede nating isolate yung k kasi basically yun naman yung kailangan natin. And so, isolating k, we now have there 2 mgy all over x squared. And so substitute the values, 2 times 95 and then times 9.8 times we have there 41. Positive na yung ginamit natin kasi dito na tayo nag-negate. So transpose na natin yan. And then divided by 11 squared. We will be left with, and so 630.9 Newton per meter. And so that will be our spring constant. Okay, with that, and so balikan natin yung question. Says there, and you had several bungee cords to select from, and you tested them by stretching them out, tying one to the end and pulling the other other end with a force of 380 newtons. When you do this, what is the distance will the bungee cord that you should select have stretch? Okay, sorry for that. And so, babalikan lang natin yung Hooke's law dito. We have there, of course, the stretching force. It's equal to, and the spring constant that we were able to solve, and then the distance. Okay, and so we're looking for the distance. So substitute, transform lang natin yung formula so that we have x is equal to fx all over k. And so substitute natin yung values na meron tayo. We have there 380 newtons divided by 630.9 newton meter. So solving for that, we'll be having 0.602 meters. Okay, so that's the answer for number 1. It will travel, it will move a distance, or it will be stretched to a distance of 0.602 meters. Okay.